Hi guys, welcome back to the channel. In this lecture, we are going to discuss about the static and kinematic theorems in plastic analysis. Okay, so basically these two theorems are helpful in calculating the collapse load of the structure, right? So in this lecture, we will be discussing these two theorems. One is static or lower bound theorem, right? And the second one is the kinematic or upper bound theorem. Okay, why these are called as lower bound theorem, we'll see later. Okay, so before coming to these two theorems, at the start of the collapse, at the start of the failure, at the start of the collapse, we need to satisfy the three conditions. Okay, so first is equilibrium condition. Okay, so in equilibrium condition, what happens is that when you are applying a load on the beam, okay, when you are applying a load on this beam and it is on the verge of collapse, let us suppose it is on the verge of collapse, so the distribution of the moment should be distribution of moments should be statically admissible. Okay, which means that your condition that summation m equals to 0 should satisfy at each and every point in this beam, right? So this is the important first condition which we need to satisfy at the just start of the collapse. Okay. Next condition is basically the yield condition. So in yield condition, what happens is that distribution of the moments due to when we applying the load, there is some distribution of the moment in this beam. Okay, and let us suppose this is the bending moment diagram of this beam. Okay. So anywhere in this beam, the bending moment diagram the bending moment value should be less than MP in value, and this is the plastic moment of the section. At the section. Okay, so bending moment diagram cannot exceed the plastic moment capacity at that point, right? So this is our yield condition. Okay, in yield condition, the moment at anywhere at the section along this beam should be less than this MP value. Okay, and if this condition, if let us suppose M is greater than MP, then the yield condition violates. Okay, right? Next is mechanism. So when you are applying a load, there is a distribution of moment, and due to this distribution of moments, if there is a formation of mechanism, okay, so that mechanism is basically showing the collapse of the structure. Okay, this mechanism is basically showing the collapse of the structure. Okay, final collapse of the structure. So mechanism is basically what? Mechanism is basically deformation without any resistance. Okay, so these are the three conditions which we need to satisfy before the start of the collapse while calculating the collapse load. Okay, so now let us come to the first theorem, which is static theorem. Okay, So in static theorem, when you are applying a load on this beam, okay, when you are applying a load on this beam or any beam, okay, so this, due to this load, there will be some distribution of moment. Okay, and these distribution of moment are satisfying the equilibrium condition. Are satisfying the equilibrium condition and yield condition. Okay. So the load, if you are applying a load W on this beam or any structure, and that due to that load, there is a distribution of moment along this beam. There will be some moment along this beam, right? So if this distribution of moment is satisfying this equilibrium condition, which is summation n equals to 0, and the yield condition, is what is the yield condition is nothing but basically that m should be less than np. Okay. So the load is the load that is satisfying these two conditions will always be less than this true collapse load. Okay. So what happens is that, let us consider this example basically. Suppose you are applying a load W on this beam. Okay. Due to this load, the bending moment diagram will look like this. Okay. So this distribution of moment, let us suppose it is satisfying the equilibrium condition plus yield condition. It is not satisfying any mechanism condition. It is satisfying only two conditions: equilibrium condition and yield condition. Okay. So this load is not due to this load, there is no collapse in the structure. Okay, but it is satisfying the equilibrium and yield condition, right? So this load, let us suppose this load should given the value W1 will be less than the collapse load. Okay, because it is satisfying the equilibrium and yield condition, and equilibrium and yield condition will not tell us that structure is collapsed or not. Okay, so this distribution of moment is satisfying these two conditions. Okay, and the load corresponding to which is W1, right? So this W1 is less than this true collapse load basically. Okay, now let us increase this load W1 to W2. Okay, and due to this load, there is a formation of one plastic hinge over here and one plastic hinge over here. Okay, plastic hinge. This is also a plastic hinge. Okay, so again, the distribution of moment will look like this. This is NP. This is NP, and I am assuming that this load is acting at the center. Okay, so you can see that again, these two conditions only will satisfy. Only these two conditions will be there. Will satisfy this distribution of moment. One, that is equilibrium plus yield. Okay, so again you can see that this W2 is not causing any collapse of this structure. Okay, due to this W2, this structure is not getting collapsed. Okay, so this W2 will always be less than PU. Okay, but this W2 is greater than W1, right? So now again, if you increase the load, if you increase the load to W3, okay, and the plastic hinge is formed under this load also. So now you can see that distribution of moment diagram will look like this. So this is MP value, this is MP, this is MP. Okay. So now this diagram is satisfying the equilibrium condition also, yield condition also, plus mechanism. Okay. So now you can say that this W3 is equals to true collapse load. Okay. So in static theorem, the load which we are getting will always be less than or equal to true collapse load. Okay. This is the condition. Now, if you are having the someone asks what is the collapse load of the structure basically. So basically for the collapse to happen, you need to increase the load. Okay. Right. So this is the basically what you can say that this is the basically the static theorem. So here you can see that this W3 load is here, which is greater than W2 is greater than W1. Okay. So in static theorem or lower bound theorem, you can see that the load which we are getting is lower bound on true collapse load. Okay. Because this W1 is satisfying these two conditions, equilibrium plus yield condition, but it is not causing any collapse, right? So this W1 is lower bound on true collapse load. Is lower bound on true collapse load. Same happens with W2. Okay, but W3 will be equals to collapse load because there the mechanism condition is satisfied. Okay, so the load which we are getting from the load which we are getting from the static theorem or lower bound theorem will always be less than equal to the true collapse load. Okay, so when it is equal, when the mechanism condition is satisfied. Okay, so now the equilibrium condition is also satisfied, yield condition is also satisfied, plus mechanism condition is satisfied, then W3 will be equals to your true collapse load. Okay, so in books you have seen this equation, seen this result that the collapse load which we are calculating from the static theorem is always less than the true collapse load. Why this is, we have already discussed, right? Now let us come to this kinematic or upper bound theorem. Okay, and how to use this theorem we will see later when we will be solving the problems. Okay, so now let us come to this kinematic theorem or upper bound theorem. So in kinematic theorem, we need to satisfy two conditions. Okay. What I mean is that when you are applying a load on this beam, let us suppose this beam. Okay. And you are getting some distribution of moments. Okay, distribution of moments. Right. So due to this distribution of moments in kinematic theorem, it will satisfy the distribution of moment will satisfy two conditions. One is equilibrium, and one is mechanism. Okay, so when what you can say that when these two conditions are satisfied, when the moment is distributed while after applying the loads, and the distribution of this moment is satisfying two conditions. One is equilibrium and one is mechanism. Okay, then the load will always be greater than the true collapse load. Okay, so why it is greater than true collapse load is basically what is happening is that if the distribution of moment is satisfying these two conditions only, equilibrium plus mechanism, but it is not satisfying any yield condition, not satisfying any yield condition. Okay, not satisfying the yield condition. That means you are applying the load, not satisfying the yield condition. First of all, what it means that M is greater than MP. That should not happen. Okay. So if that is happening, that you are applying the load which is greater than the true collapse load. Okay. So in order to achieve the true collapse load, you need to reduce the moment. Okay. You need to reduce the moment. You need to reduce the load. You need to reduce the load. Okay. So again, if let us suppose that this is the fixed beam. Okay. So one mechanism is that the hinge is forming at this point, and this point. Okay, hinge will form. Okay, one mechanism is this. Right? And you are giving the moment capacity, let us suppose, of this beam is 60 kilonewton per meter. For example. Okay. And we are assuming that the cross section is same, so the moment capacity will be same. Right? So if you are calculating the moment, if you are calculating the collapse load for this mechanism, when the plastic hinge is forming at this point, and let us suppose you are getting the collapse value, suppose 100 kilonewton. Okay. And in the next case, you are assuming that collapse is happening when the hinge is forming under this 2p load. Okay. And there you are getting the value, let us suppose P2 is equals to 80 kilonewton. Okay. So as per the kinematic theorem, the true collapse load will be 80 kilonewton. Okay. Because there are chances that this thing will not satisfy the yield condition. This thing will not satisfy the yield condition. Okay. So that thing we need to check, right? That thing we need to check whether it is satisfying the yield condition or not. If it is not satisfying the yield condition, that means you have provided the more load. Okay, that means you have provided the more load. You need to reduce this load. And if suppose by adopting this thing, you are getting this load P2 equals to 80 kilonewton, and it is also satisfying the yield condition. So this is our collapse load. Okay. So in this distribution of moment, the load which we are getting will always be greater than equals to Pu. Okay. So you have to choose the minimum value, or let us suppose if you have this condition, 3 loads are applied. Okay. So one mechanism is when the hinge is forming at this point. One is when hinge is forming at between these 2 points, and one when it is forming just at this point. Okay. So for first case, if you are calculating the value P1, second case you are calculating the value P2, and the third case you are calculating the value P3. Okay. So the minimum of P1, P2, P3 will give collapse load. Okay. So why the minimum thing will be there? Because it is already satisfying the equilibrium and mechanism condition, right? We need to check for the yield condition. Okay. And for this beam, there will be only one collapse mechanism, right? There will be only one collapse mechanism. Okay. So if you need to find the minimum load for which collapse is taking place, because that load will only satisfy the yield condition plus equilibrium plus mechanism condition. Okay. So this either from these three mechanisms only one mechanism is possible. Okay, that we have to decide by considering these three things: equilibrium, mechanism, and yield conditions. Okay, so whichever, and if you are adopting the kinematic or kinematic theorem, so the minimum value you need to take. Okay, right? Because there may be possibility that P1 and P2 is resulting in violating the yield condition. Okay, so the minimum value you have to take, because we are already assuming that beam is collapsed. Okay, we are already assuming that beam is in collapse. So we need to satisfy the yield condition, and yield condition will be correspond. You can say that you can say that the yield condition will be correspond to the minimum of these three value, or you can say that this P3 value is closest to the true collapse load. Okay, this P3 is close to the collapse load, right? So these are the two theorems which is very, very important, right? In the static theorem, the distribution of moment is important. First, distribution of moments, and we have to assume some mechanism. Okay. So I hope you understood that why this Pu is greater than P collapse load in case of kinematic, and why this P load will be less than the true collapse load in case of static theorem. Okay. If you have any doubt regarding this, you can write in the comment section. Okay, guys. So in the next lecture, we will be seeing the problems on these two theorems. Okay. So the things will get more clear, right? So if you have any doubt, you can write in the comment section. So thank you.